Okay, so we're done with all the concepts. We're done with the concepts of arithmetic progressions. We had this term formula, a plus n minus 1 times d. For AP, we had these two sum formulas, half n into 2a plus n minus 1 into d. And there was another one here as well, which was half n into a plus l, where l means the nth term. Okay, that's what we talked about. We looked at some specific cases after that as well. For example, when you have to find some terms that are between two numbers, between two terms, we talked about that, and some other examples. We talked about geometric progressions as well. This was the term; these were the term formulas, term formula, and the sum formula for a geometric progression. We looked at some examples of this as well. We talked about percentage increase and decrease here as well. And we said whenever you have a percentage increase or a percentage decrease, that means it's a GP. And we learned how to find percentage, how to find the ratio in that case as well. And then in the last session, we also talked about sum to infinity of a geometric progression. We talked about this concept. This is the formula that's given in the formula sheet. When does a sum to infinity exist? When ratio is between -1 and 1. And also we talked about convergence of a geometric progression. So a geometric progression converges when the ratio is between -1 and 1, and it does not converge when the ratio is not between -1 and 1. These were all the concepts that we did, but we did not do any questions until now. So now let's have a look at some questions from the worksheet on arithmetic and geometric progressions. Okay, so I see some questions that you have posted here. Question number 17, 25, 33. Okay, so you can let me know if there are any other questions apart from this as well. So I can see these three for now. I'll have a look at all of them and see which ones are relatively simpler. We could probably start from them and then gradually increase the difficulty level. So one is question number 17. Okay, then we have 25 and 33. Okay, so none of these questions have any kind of scenarios, as in these are not word problems. I hope you have attempted the second row of assigned questions as well. If you haven't yet, please make sure to do that as well. So for now, let's start with one of these questions, and they're not that difficult. Let's start with any of them then. Let's start with 17, and then we do 25 and 33 after this as well. Question number 17. Okay. Just copy that here. Okay, so it says a geometric progression has first term of 100 and the sum to infinity of this GP is 2000. Find the second term. Okay, so we're talking about sum to infinity and we have the first term of the GP. Now remember the sum to infinity formula, it's given in the formula sheet as well. For a geometric progression, the sum to infinity formula looks like this. Sum to infinity is equal to a over 1 minus r. Now, since we have the sum to infinity given, what we can do is we can use the sum to infinity and the first term to find the ratio. And then once we have the ratio, what we want to find is the second term. We can use the term formula for the GP. For that, term formula is AR raised to power n minus 1 to find that second term after that. But in order to be able to use this formula, you need the ratio. For ratio, you can use these pieces of information. They have given you the sum to infinity and the first term. So you can say the sum to infinity is 2000 for that value here. First term is 100, and you have 1 minus r in the denominator. You can cross multiply, 1 minus r can come here. 2000 can go here, and it becomes 100 over 2000. And then 1 minus r equals 100 over 2000. What would that be? That's 0.05. And then r equals 1 minus 0.05, which is 0.95. That's what the ratio turns out to be. Okay, the value of R is 0.95. Now what you can do is you can input this value here. The term formula is AR raised to power n minus 1. What you're looking for is the second term. What would the second term be? If n is 2, it becomes AR raised to power 2 minus 1. That's just 1, right? Now input values, A is 100, R is 0.95, and that will give you the second term, which is 95. Okay, or you could just do it mentally as well. If the first term is 100, ratio is 0.95, you just have to multiply 100 by 0.95 to get 95 directly, just in your head directly as well. Okay, that's the first term. That's the second term, sorry. That's all that you had to do in the first part. Let's look at the second part now. Now you have an arithmetic progression. Now be very careful about which sequence or which progression you're talking about. So you're using the correct formulas. A lot of people end up mixing the formulas. So clearly write that you're talking about a GP here. So the formulas that you use, they should be of GP in the first part. Now in the second part, we have an arithmetic progression. So now we're talking about an AP. So the formulas that you use, they should be of arithmetic progressions. Now, what information are we given? We're given that the third term is 90 and the fifth term is 80. So we have the value of the third term and the value of the fifth term. We need to find this first term and the common difference. Okay, now how do we think about this? We are given term 3 and we're given term 5. Term 3 is 90 and term 5 is 80. We need to find first term and common difference. That means we want A and we want D. Now, one possibility is to use the formulas, the term formula. You could use the term formula and put the third term equal to 90, put the fifth term equal to 80. You will get two simultaneous equations. You solve those two simultaneous equations and you get the values of A and D. That is one possibility. Now, I'll talk about that in a moment. But in fact, let me actually show that to you first. So the term formula for an arithmetic progression looks like this. Tn equals A plus n minus 1 times D. If you had to look for the third term, what is the third term going to be? It's A plus 3 minus 1, that's 2 times D. And the value of the third term we know is 90. So we get one equation that's 90 equals A plus 2D. And similarly, we can find the fifth term using the same formula. A plus 5 minus 1, that means 4, A plus 4 times D. T5 is 80. So we get 80 equal to A plus 4 times D. You've got these two equations, solve them simultaneously, and you would get the values of A and D. We could make A the subject from both of them, 90 minus 2D. For the second one, you get 80 minus 4D. Now you could equate both of them. 90 minus 2D, that equals 80 minus 4D. 2D equals minus 10, and the difference turns out to be minus 5. If the difference is minus 5, now you can find the value of A as well. A equals 90 minus 2 into minus 5. That's 90 plus 10, which is 100. So the first term is 100. And the difference is minus 5. Now, this is one way to do it, and that's perfectly okay. You just use the term formulas, and you get the result. Okay, this is one possibility, but it's only a 3-mark question. It's in fact a 2-mark question only. Since it's an arithmetic progression, you could actually just do it in your head directly as well. Let me show you how that could be done. T3 is 90 and T5 is 80. What are we looking for? We are looking for the first term and the difference. What is the first term going to be? And what is the difference going to be? Now you see, it's an arithmetic progression. In an arithmetic progression, the difference between terms is constant. Now you see, we have a gap of 2 terms here, and we have a gap of 2 terms here as well. So T3 is basically in the middle of T1 and T5. Since it's an AP and the difference is constant, whatever is the difference between T3 and T5, both of them have a gap of 2 terms. These 2 terms also have a gap of 2 terms. The differences between them are also going to be constant. If this difference is 10, in fact, it's minus 10. What about this difference? This would be minus 10 as well. So if this value is 90, this should have been 100. So that 100 minus 10 gives you 90. So you could do it in your head as well. You could say T1 equals 100 directly. Okay. And then what about the difference? If this value is 100 and you have to go to 90, which is the third term, what about the second term? What should that be? Between 100 and 90, that should be 95. And that tells you the difference between the terms. The difference between the terms is 95 minus 100. That is minus 5. So the 2 marks that you have, they are just for the answers in this case. You could actually figure this out in your head as well. You could say the first term is 100. And just by looking at the sequence, you could figure out that the difference is minus 5. If you understand that, that's great. You could write down the answers directly. If not, this would be the proper way of doing this. That would work in any similar scenario, that you make 2 equations, solve them simultaneously. If, for example, in case of T3, you had some, if instead of T3 and T5, you had some other terms, maybe T10 and T25, in that case, it would not have been as straightforward to do it mentally like this. And you would have to use this proper method for that. So you need to understand this method for sure. But in this particular example, since it was just T3 and T5, it was relatively straightforward to figure that out directly without much working as well. And that's the second method that I showed to you. Is that okay? Any questions on this? No?
No, sir.
Okay, so that was part B1. Okay, now we have the second part of B that says find the value of M given that the sum of the first M terms is equal to the sum of the first M plus 1 terms. Sum of the first M terms. What does that mean? That means SM. That equals sum of the first M plus 1 terms. That means SM plus 1. These two have to be equal. Okay. Now, since you have already found the first term and the common difference, one possible way of doing this could be that you just say SM equals SM plus 1. That's what they're saying. Sum of the first M terms is equal to the sum of the first M plus 1 terms. Now, we know the value of A and the value of D. A is 100, D is minus 5. You could just input those values in the sum formula for an AP. Remember what the sum formula for an AP is? It's given in the formula sheet like this: half into N into 2A plus N minus 1 times the difference. Just input values in that. In place of N, you got M here. So you could say it's half M into 2 times A. A is 100 plus N minus 1. That means M minus 1 times the difference, which is minus 5. This should equal SM plus 1. That instead of N in this formula, you need to have M plus 1. So on the right side, that's what you do now. Now you have SM plus 1. That means half into N. That's M plus 1 here. Into 2 times A. That means 2 into 100 plus M plus 1 minus 1. M plus 1 minus 1 times the difference, which is minus 5. and then the bracket is closed. Okay. And now you can simplify this, find the value of m. This is one way of doing this. Okay, let's see what we get from this. Half and half on both sides, they get cancelled, right? 2 goes to the other side, gets multiplied in 2 over 2. That gives you 1. So we can just cancel these out. What are we left with? Let's simplify the numerator. M into 200 minus 5m plus 5, that equals m plus 1 multiplied by 200 minus 5 times m, right? Because m plus 1 minus 1, we are only left with m there. This is what we end up with. Now let's simplify this further. This gives us 200m minus 5m squared plus 5m equals m plus 1 into 200 minus 5m. What does that give us? 200m minus 5m squared plus 200 minus 5m. Take everything to one side. You would see that these two would get cancelled, and we're going to be left with 200m plus 5m, that's 205m. And then this comes to the left side as well. In fact, they also get cancelled. These two get cancelled. 5m plus 5m, that becomes 10m. On the other side, you just have 200. The value of m turns out to be 20, and that is what we were looking for. Okay? So you just equate the sum of the first m terms to the sum of the first m plus 1 terms, and that gives you the result. That gives you the value of m. Okay? Now, this is one way of doing this. There could be another way of thinking about this, and that's going to be much quicker. You see, it says sum of the first m terms is equal to the sum of the first m plus 1 terms. Now, what does that mean? Let's suppose m was some number. So let's say m was 50. So for now, let's assume we do not know what the value of m is. If m was 50, for instance, what they're saying is sum of the first 50 terms is equal to the sum of the first 51 terms. 50 plus 1, that's 51. That's what they're saying. That the sum of the first 50 terms, that's equal to the sum of the first 51 terms. Now, how is that possible? That's only possible if the 51st term was equal to 0. Right? Because then we can say whatever was the sum of the first 50 terms, when we add 51st term to that, the sum remains the same. So the 51st term, that means, has to be equal to 0. Now, if we think of the same thing in terms of m, we could say something like this. We could say, what is sum of the first m plus 1 terms? That's the same thing as saying, if sum of the first m plus 1 terms and the sum of the first m terms is equal, that means tm plus 1, that is going to be equal to 0. The m plus first term is going to be equal to 0, because adding that term is not making any difference to the sum. Okay, and now using that, we could say the term formula for a GP, now for an AP, in fact, is a plus n minus 1 times d. We say, let's find tm plus 1. What would that be? The first term was 100. In place of n, you input m plus 1. So m plus 1 minus 1 into minus 5. Since tm plus 1 is supposed to be 0, we put 0 here, and that gives you 100 minus 5 times m, and that gives you the value of m directly, which is 20. And that would have been slightly quicker as compared to what we did above. If you are able to figure out that if these two sums are equal, then the m plus first term, that has to be equal to 0. Is that okay? Make sense?
Yes, sir.
All right. Okay, let's move on to the next one now. That was part 2. Now it says, find the value of n, given that the sum of the first n terms is 0. So now they're saying Sn, sum of the first n terms, that means Sn, that is equal to 0. We have to find the value of n. Now, that's pretty straightforward again. What they're saying is, sum of the first n terms, that means Sn is supposed to be equal to 0. So now just input values in the formula, half n into 2 times a, that means 2 times 100, plus n minus 1 times the difference. The difference was minus 5. That equals 0. 2 goes to the other side, gets multiplied by 0. N goes to the other side, 0 over n, that also gives you 0. What are we left with? 200 minus 5n plus 5. Okay, because when this whole thing goes to the other side, it gets eliminated. So it's basically 0 into 2 over n, that gets eliminated. So we have 200 minus 5n, 205 minus 5n equal to 0, and n equals 205 over 5. That I think is 41, right? N turns out to be 41. If the sum of the first n terms is 0, the value of n is supposed to be 41. Okay, that was the third part. That's question number 17. So the next one that you have now is 25. Okay, let's have a look at the next one. Question number 25. Okay, so now this is, in an arithmetic progression, the sum of the first n terms denoted by Sn is given by this. Find the first term and the common difference. So what they've done is, they have given you the sum formula for this particular arithmetic progression. And they're saying that sum formula is n squared plus 8n. Right? This is the sum formula that they have given us for this particular arithmetic progression. Now, what's the general sum formula for any arithmetic progression? That looks like this: half n into 2a plus n minus 1 times the difference. This is the formula that they have given us in the question. They're saying for this particular arithmetic progression, the sum is given by n squared plus 8n. But in general, the formula looks like this. What you can do now is, you can compare these two to figure out what the value of A should be and what the value of D should be. That's one way of doing this. That they have given you one formula, you have your own formula as well. Just compare the two to find the value of A and the value of D. Now, how do you compare them? In order for you to be able to compare them, you need both of them to be in the same. Now, in this case, they have one n squared term and they have one n term. You want to compare this formula to the formula that they have given. So you want to simplify this other formula in a form such that it also becomes these two terms, one n squared term and one n term. Now, how will that happen? We can simplify this and see what that gives us. Multiply half n inside and see what it turns out to be. Half n into 2a. 2 and 2 get cancelled, and we're left with a times n. And then half n into this whole thing. That's half n into n minus 1 times the difference. Okay, now let's simplify this further. It becomes an plus half n into d. Let me write it like this first. to make it less confusing, half into dn into n minus 1. So I've multiplied d first, and then you multiply it inside the bracket. So it becomes half dn squared minus half dn. Okay. Now, what are the two terms that you need? One n square term and one n term. Now you have an n square term here, and you have two n terms. What you can do is you can write the n square term first, just like they have here. That's half dn squared. And then write the coefficient of n from these two terms. What's the coefficient of n? The coefficient of n turns out to be, if you take n common from these two terms, that gives you a minus half d whole multiplied by n. Now you have converted the sum formula to the form that they had given here. Now you can compare the two. The sum formula that you are getting looks like this. It's half bn squared plus a minus half d into n. In their formula, the coefficient of n squared, what's that? That's 1. If there's nothing outside, that means it's 1, right? So the coefficient of n squared is 1 here. In the form that you have, the coefficient of n squared is half d. So you can compare the two and say half d should equal 1, and that gives you d equal to 2. And similarly, the coefficient of n there is 8. The coefficient of n that you have is a minus half d. You compare these two as well. You say a minus 1 over 2 times d should equal 8. And now you know the value of d already. So it becomes a minus 1 over 2 times 2 equals 8. And the value of a turns out to be 8 plus 1, which is 9. This is the first term that we're getting and the difference that we're getting. A equals 9 and d equals 2. Okay, so you sometimes have to do this, that you have to compare the formulas like this. When do you have to do that? When they give you a formula themselves. So they've given you a sum formula here that looks like this, n squared plus 8n. What you can do is you can find your own sum formula using the one that's given in the formula sheet, then compare the two to find any unknowns that you have, because both of these are sum formulas. That means they have to be identical to each other, right? Since they have the same variables, both of them have something in terms of n. So you have one n squared term, one n term. We just compare those two terms and find the value of a and b from that. Okay. This is one way of doing this. You need to know this method. Sometimes this is the only method that works. Okay. But again, in this particular problem, you could think of it one other way as well. Now, you need to make sure that you understand this method, comparing coefficients. Okay. You do sometimes need to do this, and that would be the only method in some questions. However, in this case, you could also do something else. We know it's an arithmetic progression. And for this arithmetic progression, we know that the sum formula is n squared plus 8 times n. What we are looking for is the first term and the difference. That's what we're looking for. Another possibility could be that you find the sum of a certain number of terms using the sum formula, right? What is the sum formula supposed to do? With whatever value of n you input, it's supposed to give you the sum of that AP. For example, if I input n equal to 10, this thing is going to give me the sum of the first 10 terms. We can use that to figure out what the first term is and what the difference is. How do we do that? Let's input the value of n as 1 here and see what that gives us. If n was 1, we would get S1 equal to 1 squared plus 8 times 1. What does that turn out to be? 9. That means the sum of the first term is 9. Now, sum of the first term, that means there's only one term, and that term is 9. And that's all that we were looking for. The first term, therefore, is supposed to be 9. Similarly, now we can input n equal to 2 and see what that gives us. If n equals 2, h2 turns out to be 2 squared plus 8 into 2, and that is 20. This is the second term. So we have an arithmetic progression in which the first term is 9 and the second term is 20, and so on. What's the difference? No, I'm sorry. The second term is not 20. What we know is that the sum of the first term is 9. The sum of the first two terms is 20. If sum of the first two terms is 20, what that means is term 1 plus term 2, that equals 20, right? Sum of the first two terms is 20. We already know the first term. The first term is 9. So we can say 9 plus t2, that equals 11. So that equals 20. t2 equals 11. The second term turns out to be 11. Now the first term is 9. The second term is 11. What about the difference? Difference would be 11 minus 9, and that gives you 2. That could be another way of thinking about this. Okay? By just inputting values. Input n equals 1, that gives you the first term. Input n equals 2, that gives you the sum of the first two terms. You can use that to find the difference. Make sense? Any questions on this? No? Okay, good. Let's have a look at the next one now. That was part A. Let's look at part B. Part B says, in a GP, in a geometric progression now, the second term is 9 less than the first term. The sum of the second and third terms is 30. Given that all the terms of the progression are positive, find the first term. Okay. So first of all, we have a geometric progression. Okay, keep that in mind. It's a GP. And they're saying we have a first term, we have a second term. Let's call the first term A. We don't know what the value of the first term is. However, they're saying the second term is 9 less than this first term. If the first term is A, what is the second term supposed to be? It's supposed to be A minus 9. So we say the second term is A minus 9. Okay. And then they're saying the sum of the second and the third terms is 30. Now, whatever is the third term, they're saying T2 plus T3 is supposed to be equal to 30. Now we know the second term already. We know that the second term is A minus 9. In terms of A, we know that. If the second term is A minus 9, let's input that here. We can say it's A minus 9. So A minus 9 plus T3, that equals 30. Can we find T3 in terms of A as well? T3 turns out to be 30 plus 9, which is 39, minus A. So T3 turns out to be 39 minus A. So now we have the first three terms of the GP in this form. In terms of A, the first term is A, the second is A minus 9, and the third is 39 minus A. Okay, now what are we looking for? We need to find the first term. That means the value of A. That's what we want to find out. It's a geometric progression. Remember, in a geometric progression, the ratio of the terms is equal. So we could say, remember we've talked about this before when we did GP. If we have 3 consecutive terms of a GP like this, we could find the ratio by dividing the second term by the first term. And we could also find the ratio by dividing the third term by the second term. That gives us an equation, this part. That basically gives us that a minus 9 over a, that should equal 39 minus a divided by a minus 9. And that gives us this equation. It's going to be a quadratic equation. We can solve this and find the value of a from this. Okay, let's cross multiply. That gives us a minus 9 whole squared. That equals a into 39 minus a. We get a squared minus 18a plus 81. That equals 39a minus a squared. Let's take everything to one side. That gives us 2a squared minus 57a plus 81 equals 0. Now, can we factorize this? 2 into 81, that's 162. And we have 57 here. Need to add something. 50 into 7 is going to be too big. 52 into 5 is not that. 54 into 3. 54 and 3, they work. So we can say 2a squared minus 54a minus 3a plus 81 equals 0. And we get two factors from this. 2a minus 3 and a minus 27. Okay, that means a either equals 3 over 2 or a equals 27. These are the two possible values of a that we're getting. These are two values. We need to figure out whether both of them are possible. What does the question statement say? Let's have a look at that. Okay, so the question statement says, find the first term. That means it's got to be one single answer. We are getting two answers. We have a equals 3 over 2 and 27. One of them is supposed to be incorrect. Okay. Now, how do we decide which one we have to ignore? Let's see what what other information they've given us here. They're saying all the terms of the progression are positive. Okay, all the terms are positive. If the first term was 3 over 2, what's the second term? A minus 9. That means 3 over 2 minus 9. The second term would become negative if a was 3 over 2. So that means 3 over 2 here is not possible. Why? Because if a was 3 over 2, the second term would become negative. And any term in this progression, they are saying cannot be negative. All terms are positive. So the only answer that we have, therefore, is a equal to 27. That's the only answer that we've got. Okay, and that's what we were looking for. Is that okay?
Yes, sir.
Okay, good. That was part B of this. Let's have a look at one more. So the next one that you were asking about was question number 33. Let's try that. We will need one more class in this. I hope you can now complete the worksheet, attempt the rest of the questions as well. So that if there are any other problems, you can let me know about them as well. We haven't covered any questions in which you have some scenarios given. For example, question number 34, in this case, they have a real life situation that is going to be converted to either an AP or a GP and then solved. So make sure that you attempt all the assigned questions. And then we can discuss them in the next class if there are any problems. Okay, question number 33. Let's try this now. Okay, so it says in an arithmetic progression, the sum of the first 10 terms is 400. Okay, now how do you write that? Sum of the first 10 terms is 400 and it's an AP. And the sum of the next 10 terms, what does that mean? Next 10 terms. That means from term 11 to term 20. This sum is 1000. Find the common difference and the first term. We need to find the value of D and the value of A. Now remember, we've talked about this before. How do you find sum of all the terms from 11 to 20? What we can do for this is we can say find the sum of the first 20 terms, right? Find the sum of all 20 terms. Subtract from that the sum of the first 10 terms. And that would leave you with sum of all the terms from 11 to 20, from 11th term to the 20th term. Okay, so you do S20 minus S10. So that means sum of the first 20 terms minus sum of the first 10 terms, that should equal 1000. Now you already know sum of the first 10 terms is 400. So you say it becomes S20 minus 400 equals 1000. So the sum of the first 20 terms, therefore, is 1400. So S10 is 400, S20 is 1400. We can make two equations using this and solve them simultaneously. Remember the sum formula that we've got? This is the sum formula. Half n into 2 times a plus n minus 1 times the difference. Let's find S10. What would S10 be? Half into 10 into 2 times a plus n minus 1. That means 10 minus 1, which is 9 times the difference. This should equal 400. 400 equals 5 into 2a plus 9b. This is one equation that we're getting. And then we have S20. S20 turns out to be half into 20 into 2a plus n minus 1. What's 20 minus 1? It's 19 times the difference. S20 is 1400. So we say 1400 equals 10 into 2a plus 19 times d. Now we just solve these two equations simultaneously, and that's going to give us the value of a and the value of d. Okay. We could divide 5 on the other side to simplify this a bit. That gives us 80 equal to 2a plus 9d. That's one equation. From the other equation, we divide 10 on the other side. That gives us 140 equals 2a plus 19 times d. Now we could make 2a the subject from both sides. 140 minus 19d, since we have 2a here as well, we just use that. We could say 2a equals 80 minus 9d. Instead of 2a, put 80 minus 9d in the second equation. 80 minus 9d, that equals 140 minus 19d. You could make a the subject as well, and that's perfectly okay. You could divide by 2 on both sides and then equate them. It's the same thing. Now, what do we get from this? 10d equals 140 minus 80, that's 60. The difference turns out to be 6. Put this back in any one of those two equations. Let's say here, we get 2a equals 80 minus 9 into 6. And the value of a turns out to be 80 minus 9 into 6. That's 26 divided by 2, 13. The first term is 13. So we have the first term and we have the difference. That's what we were looking for. All right. That was part A. Then in the second part, it says, a geometric progression has first term A, common ratio R, and sum to infinity 6. A second geometric progression has first term 2A, common ratio R squared, and sum to infinity 7. Find the values of A and R. This also looks relatively straightforward because you just have to make two simultaneous equations. Both of them are GP now. For one GP, they're saying the first term is A, ratio is R, and the sum to infinity is 6. That's the first GP. And for the second GP, they're saying for GP2, the first term, in place of A, we have 2A. Ratio is R squared, and sum to infinity is 7. We need to find the values of A and R. What's the sum to infinity formula? AS. Sum to infinity is given by A over 1 minus R. Okay, that means we get one equation like this. 6 equals A over 1 minus R. That's one equation. And from the second case, we get sum to infinity equals A over 1 minus R. But the first term here is 2A. So that becomes 2A over 1 minus the ratio. The ratio is R squared. So we have 1 minus R squared. Sum to infinity is 7. We put that here. 7 equals 2A over 1 minus R squared. These are two simultaneous equations. We can just solve them and find the values of A and R. We could make A the subject in both of them. A equals 6 minus 6R. And the second equation, we could get 2A equals 7 minus 7R squared. And then A equals, or just input that here directly. Let's input this here. And that gives you 2 into 6 minus 6A. Sorry, 6 minus 6R. That equals 7 minus 7R squared. So in place of A, I've input 6 minus 6R. And now we simplify this, it becomes 12 minus 12R equals 7 minus 7R squared. We get a quadratic equation again. 7R squared minus 12R plus 5 equals 0. Can you factorize this? 7 into 5 is 35. We need to add and get 35 somehow. 7 and 5, yeah, so we can use the same. 7R squared minus 7R minus 5R plus 5 equals 0. And that gives us two factors, 7R minus 5 and R minus 1. Ratio either equals 5 over 7 or the ratio equals 1. These are the two possible values of R that we're getting. Now, think about it. If ratio is 1, what does that mean? What is the GP going to be like? The first GP? It's going to be the same number repeated. If the ratio is 1, that means you're multiplying by 1 to get the next value. It will be the same number repeated again and again and again. Does the sum to infinity exist in that case? Remember the condition for sum to infinity? Sum to infinity only exists when ratio is between -1 and 1. It's between -1 and 1. It should not be equal to 1 or equal to -1. If that is the case, the sum to infinity would not exist. So the sum to infinity, if R was equal to 1, would not exist. So what do we say then? This is not possible. So the only value of R that we have is 5 over 7. Now we put that back in the first equation, and that will give us A equals 6 minus 6 times 5 over 7. That's 6 minus 30 over 7. That's 12 over 7. The value of A turns out to be 12 over 7. And that's what we were looking for. We got A and R. Make sense? Any questions on this? Okay, good. So we did questions 17, 25, and 33 today. If you haven't attempted the whole worksheet yet, please make sure to attempt the rest of the questions as well. And let me know the problems that you have. In the next class, our next class is on Friday. We would start around 2:25, 2:30 on Friday. And in that class, we will be doing some more practice questions. So make sure that you attempt all the questions so that we can wrap this topic up in our next class, inshallah, by doing the rest of the questions. Okay. Anything else before we end today? Anything that you might want to ask? By the way, those of you who were taking the S1 course as well, we would want to have a couple of extra classes in that as well, in case you have any practice, if you have any problems on any particular topics. So let me know if you have any questions on any S1 topics as well. We could schedule 1 or 2 more classes on that to discuss those questions. Okay. But that's it for today then. I think you don't have any further questions, so we will end it here. All right. Okay. Allah Hafiz then.